Welcome everyone to the session of the DMP Common Standards Working Group. My name is Tomasz Miksa, and together with my co-chairs Paul Walk and Peter Nash, I would like you to welcome us in this session on machine-actionable DMPs. The agenda for today that we have prepared is as follows. We'll have 4 parts of the session. The first one will be a short introduction for newcomers, if we have any here, status update and meeting objectives. And then in the second part, we will have 6 presentations. Each presentation will be around 5–8 minutes long. We'll hear about different existing, pending, or planned adoptions of the recommendations for MADMPs. After each of the presentations, there will be a chance to ask 1 or 2 questions. Since we are not such a big group, I think we can simply try asking questions by unmuting and talking to the microphone. In case there are too many questions, then maybe we'll switch to chat. Let's see how it works out. In part 3, we will talk about the maintenance of the recommendation. So there are some minor changes we have made recently to the specification, and we would like to inform you about these changes and also discuss how future changes and improvements to the recommendation will be handled. And in the last step, in the last part, we would like to discuss any topic you may have related to DMPs and plan what can we do for the next plenary meeting. Before we start with the introduction, I would like to remind you that we have a collaborative notes link, which you can find in the website of this session. So if you go to the website from the agenda, there will be a link to the Google Notes. So please add your name to the list and please help in taking meeting notes. And I would also like to now invite you to Slido. Please go to Slido, to this website. We have 3 questions for you. We would like to simply get to know you a bit better, know who you are and what's your background. So please scan this QR code and go to Slido. You can do it using your mobile phone. And we have a first question for you. How familiar are you with MADMPs? So for the first time in this session of DMP Common Standards Working Group, or you've been following the developments, have you been to other sessions? You already adopted a standard recommendation, or maybe you are here because you heard a lot about MADMPs and you're simply planning to adopt it. So please vote, please let us know. So I see we have mostly people who are for the first time here, great. Adopting already, second option, following developments, actively contributing, or planning adoption, okay, that's also good. For us, we've got 16 votes. We have 27 people in the room, so I'm waiting also for some more votes. 17. So first time here, almost half of you, great. Because this means that we can reach out to a new community. 19. Will we get 20 votes? Anyone else?
How do you vote?
Okay, let's go to the next question. Where are you located? So where do you come from? It can be a country, it can be, you know, if you're sitting in a bunker, you can also tell us that. Okay, so I see we have people from Europe, we have people from US, we have people staying in the mountains, people staying on a chair or in a chair. UK and Netherlands being the primary sources. 19 votes, 20, same as before, I guess, okay. Let's continue. Oh, we got 20. And the last one is tricky. I'm really curious how you will answer this question. So Earth is flat or round? 50-50, round.
There should be an option for other.
No, we deliberately went only for these two. because we want to find out how many people, how should we take the feedback from people, if it's serious feedback or if they are simply trolling us, or you know, those who said flat, maybe we shouldn't take them seriously. Okay, most of you got it right, it's round. So thank you very much. So we know that we have many people who are first time here. Majority of you knows the Earth is flat, and that you're coming from different places, not only from Europe or not only from the from Americas. Great. So let's go to part one, to the introduction to the newcomers. So it all started with a big bang. But seriously, it all started in 2017 when this group was established. It was established as a result of a consultation made by the active DMPs interest group. And that group identified a need for a new working group that could focus on developing a common standard to represent information in DMPs. So the assumption was, and I think this is still true, that a lot of information in traditional DMPs is manually completed, and it's kind of vague. There are some questionnaires people have to fill out to provide answers. And then it's very hard to reuse this information to find out how the data should be used, what the data is, because it's not really well structured. A lot depends on the scientific honesty of the person writing it. And machine-actionable DMPs is a concept that should, in principle, automate data management. So it should help in collecting information from systems, but also should help in triggering actions in other systems. I will provide some examples of such actions later. One of the benefits is also that it can facilitate validation of a DMP. This is something that especially the funders were looking forward to, so that you don't need to read the long PDF, but you can have a set of filters and can, for example, quickly identify where the data is, what license has been issued, and whether there are any sensitive issues. And to build such an automated system, we need three things. We need well-defined RDM workflows, research data management workflows, meaning all different stakeholders involved in management of data need to have well-defined roles. So a researcher can provide parts of information, but research support some other part of the information, the IT support, repositories. This is a game of several people who can contribute to writing a DMP and can also get the information from a DMP. Second thing we need data infrastructure, data management infrastructure that actually facilitates this communication. So we need tools, we need repositories, so we need basically communication channels between these tools. And the final thing, which is in focus of this working group, is a common way to represent this information. So the common way to represent information which is covered by DMPs. Let me give you an example. At the top of this slide, you can see the way the DMPs currently describe information provided by the researchers. So what they do is that they model questionnaires. You can see a question, who is the contact person for the DMP? And an answer from someone saying that the PI will be John Smith from our university. And it's very hard to write a tool that can automatically query this kind of information and say, and to find out who the contact person for DMP is, because this would require parsing the text, and this is not a straightforward activity. Machine-actionable DMPs, in turn, model information. So this is basically the same information as at the top of the slide, what you can see in the bottom of this slide, but divided, split into specific fields. And here we can see an exact email address of John Smith. We can know that the name is John Smith, and we also know how we can identify John Smith with a person identifier, in this case, ORCID. So machine-actionable DMPs break down information and model information, not questionnaires, and also make sure that information is very specific, and they reuse existing standards defined for other purposes. They also require using persistent identifiers when necessary and when possible. all the work done by this working group has been summarized in form of an output that became a recommendation. So if you want to read more about machine-actionable DMPs, you can go to the website of the working group, where you can find the 2-pager explaining briefly what MADMPs are about, and it will also point you to more extensible documentation on GitHub. This is an example of the documentation, so you can see here a list of fields, their description, and some example values and cardinality. Most of the fields are optional, so this means that MADMPs are a common way to exchange information between the systems, and they have to work in a variety of settings. So they are not bound to any specific funder template in Europe or in the US or in Latin America. Those who are using this specification can set specific constraints. So they may say, okay, in our setting, we require researchers to provide information about the costs, while in some other settings, not necessarily. And to keep in mind, MADMPs are not a questionnaire and not a template. So they are not meant to replace any template provided by the funder. They are just a way to model the information that underlies the templates requested by funders or requested in other settings. So one of the examples of how we can use MADMPs is in this figure. So we imagine you have 3 actors here: researcher, repository operator, and funder, and they interact with each other by exchanging MADMPs. So for example, researcher describes the data in the DMP and says that given data set will be put into repository A, and it will be published under the CC BY license after 2 years of embargo. And once this information has been put in by a researcher into the machine-actionable DMP, the repository operator can automatically read out this information from the DMP. There is no need for the repository operator to ask again the researcher at the upload of a data set what is the license, what is the embargo, because this can be automatically read from the DMP. In return, when the data gets deposited, the repository operator can append to the data management plan a DOI of this document, of this data set, and can also provide estimations on costs, how much it will cost to curate and preserve the documents. This is not something researchers usually know, and this can be provided by the repository operator to enrich the information in the DMP. And such a DMP can be transferred to the funder, and funder gets a list of DOIs because very often the funders wants to see whether the data was really published or not, want to find out about the costs and other information contained in the DMP. This is a very simplified scenario, but realistic. And MADMPs are engineered for a variety of cases, not only to make the funders happy, or not only to facilitate the repository operators. Other options are also possible. So the recommendation has been issued, and we have currently a set of pending or finished adoptions. We have here most of the DMP tool providers: DMP Online, DMP Tool, Data Stewardship Wizard, LDM Organizer. We have also some publishers like F1000 Research. We have also one data repository, Haplo, and some projects like Fair Data Austria that is building infrastructure using MADMPs in Austria. This is only a selected set of adoptions we have. And if you're interested in the DMPs, you would like to learn more about what others are doing with respect to MADMPs, you can check out the website of the hackathon, which took place in May 2020. We had a lot of participants, a lot of teams, and go there, you can see the results and reports from each of the group if you're interested in this topic. This is all from me. Are there any questions from the newcomers? Is there anything you would like to ask now before we continue?
Maybe one question. it's a very interesting approach you're taking. And you mentioned also that, say, for instance, because embargo rules or so are already explained in the DMP at the moment where you're ingesting something in a repository or so, you don't need to bother about it anymore. Have you thought about exceptions? I mean, it's a real world we're all living in, and sometimes things don't work out as anticipated or need to be handled exceptionally. How does that relate to a machine-actionable DMP?
I don't have any good example of such an exception. Are you able to provide one?
Yeah, I mean, for instance, there was mentioning about DOIs for persistent identifiers. So suppose that is part of the DMP, but say at a certain point, for technical reasons, you would need a handle instead of a DOI, and you need to register that somehow. Would the system allow for that, or would you need to change then the description of the DMP to allow such a thing?
So the DMP is a living document, and we have a mechanism for versioning. So whenever there is an update, such an update can be sent by the tool, by the source of the change, and can then simply change the data set from DOI to a handle. There will be a presentation today discussing actually this specific issue. So please wait for this one. But in general, we have a mechanism for versioning. And please keep in mind that this is a specification for allowing the exchange of information to the systems. How systems deal internally with the changes, how they do it, how they represent the information even, it's a completely different thing, independent of the standard.
Okay, thanks.
Okay. Tomasz, in one of the slides you were referring to a repository operator. Didn't you have a data steward in mind, rather?
It can be both. It depends on how you define the data steward. If you see the data steward as a person who is facilitating creation of the DMP and is a kind of an advisor to the researcher, you can also include the steward in the loop. But here, with the repository operator, we rather thought of someone who is hosting a repository. And then when you upload the data into the repository, it automatically updates the DMP. So repository operator as a person who is managing the system where the data is located, yeah?
Okay, okay, thanks. Mm-hmm.
Thank you.
Tomasz?
Yes?
This is Ted Haberman, and I'm looking at this talk handout, and there is an acronym in it in that's RDM, and someone said that's research data management, which sort of makes sense, but it doesn't seem to make sense in some of these sentences. What is RDM stand for research data management in this document?
I think you're referring to the handout from one of the presenters who are going to present. But yes, in this context, and always whenever we talk here, RDM stands for Research Data Management. I think you're referring to the handout from Max, who is going to present later today.
It could be, yeah.
But RDM stands for Research Data Management here for sure. I don't know the contents of the handout.
Yeah, okay, thanks.
Okay, let's move on to the second part, if I may. So in this one, we want to focus on the existing pending and planned adoptions, and we 6 talks foreseen. So I would like to ask Claire to start sharing her screen. Claire, are you ready? Claire? We cannot hear you.
Yeah. Claire's on mute.
Claire, you're muted.
Okay, how's that?
Now we can hear you.
Okay. All right, and I shared my screen. You see that?
Yes, we can see it. It's not full screen, though.
Right. So I'm making it full screen. There we go.
We are seeing the presenter mode right now.
You're not seeing, so I shared my screen and I have it full screen in my presentation. You don't see that?
We are seeing the presenter mode, so we see the main slide and also the next slide.
Oh. Well, I think that doesn't matter.
That's fine. Yes, please continue.
Okay. So thank you, everybody. I'm really very thrilled to be here, and I want to congratulate this work group for the absolutely fantastic job that you've done in developing this MA DMP. Let me see. Okay. Before I start, I need to specify that in this presentation, all views are my own. I'm not speaking in the role of an official government spokesperson, and I am not making explicit comments or recommendations on or explicit discussions about Canadian statutory, regulatory, or policy matters or data, and I declare that I have no conflicts of interest. So I want to start here at the high general level and move toward the specifics, more specifically to the topic of DMPs and machine-actionable DMPs. So just 2 weeks ago, there was a joint appeal for open science from UNESCO, WHO, CERN, and the Human Rights High Commission for Human Rights. And I nearly fell off my chair when I saw this, I heard it. Data are a vital human rights tool, declares Michelle Bachelet, who is the United Nations High Commissioner for Human Rights. And I think this is, the open science has been gaining momentum for a number of years now, but this really, I think, ups the stakes in the seriousness with which we need to view data and data management. And if we move back, if I can find my cursor, to May 2020, where the OECD highlighted that open science is critical to preventing and combating pandemics, and referring also to fair data principles, which are an integral part of open science. And if I go back to last year, CODATA defines, in the Beijing Declaration, defines data not only as data in the strict sense, but the ecosystem of all digital things relating to data. And I would suggest that those things need to be reflected in the DMP, in the machine-actionable DMP. In government, we have a lot of policies and directives which, by definition, are mandatory. I did an exercise last year to discover all of the requirements and drivers that I could find relating to data in the various policies and directives. I found 59 of them, which inspired this 59-sided geometric shape. So it starts with open government, open by default, by design, open standards, and so on, including testing the data for unintended biases and that AI, artificial intelligence outcomes are monitored. So the exercise then led to discovering how to reflect these mandatory requirements in a DMP. So we're taking a very close look. It's not adopted, but we're taking a very, very close look at the RDA MA DMP and as a core requirement for data management plans, and then looking to see how we can add on these other requirements that should be reflected in the DMP. And so without separating what is already included in the RDA core DMP, I've listed a few of the issues or requirements that need to be reflected in a government context, beginning with open science, and then moving down to data quality, computer code sharing, inventory, cross-government inventory of data, and criticality of the data. Is it critical for the minister, the deputy minister, and various programs? And one thing that we have in government that is probably not existing with researchers in universities, approvals are very, very integral to all of the work that we do in government. And so the idea is that a machine-actionable DMP would be able to automatically generate an analysis or a report on what the researcher or the operations people have prepared in the DMP, and the manager then would simply be able to click on approve, not approved, based on the automatically generated report from the DMP. This is all wishful thinking at this moment, conceptual, let's put it that way. Doesn't exist at this point. And so the recommendation that I have, to give you some insight into my very weird sense of humor, I suggest that when folks read through these mandatory policies and directives, they sing the 59th Bridge Street song, which, if you recall, and I may be sharing my age with this also, it's feeling groovy. I have a preprint that is available that I can try and remember to put into the chat that gives you a link to the policies and directives identified, out of which we can pull bits and pieces related to data and ultimately connect them to a DMP. With that, thank you very much. And I'll stop sharing.
Thank you very much, Claire. We have room for one question.
This is Ted Haberman. I asked in the chat, so the approvals, I agree that, I mean, I understand the importance of those approvals. Does that mean that machine actionable DMPs need some kind of digital signature capability that can accept sort of some signature as an indicator of approval and
right.
in a secure
yeah.
way?
Right. So the idea is that the DMP would be linked to the data lifecycle, and part of that data lifecycle is step number one, creating the DMP, and then step number two might be registering it in a repository of DMPs, and step number three might be it landing on the manager's desk and exactly right, an electronic signature to approve or not approve to send back for revision before it's approved.
But then there might be also similar things associated with different steps in the DMP, right? Or different research outputs or something that might also need to be approved. Yeah?
Yeah, conceivably that could be the case. So I just want to emphasize that this is all conceptual at this point. Nothing implemented or adopted yet.
Thank you very much. We have to move to the next speaker, to Maria. Are you ready, Maria, to share your screen?
I'm ready, yeah. Let me go
Please
ahead.
go on.
Great. Alrighty. So my name is Maria Pretzelis. I'm with the California Digital Library. I work in the UC3 department. We work on maintaining, preserving, and adding value to digital research data throughout the whole life cycle. So similar to what Claire was talking about, there's really been kind of a larger call for open science practices in the United States as well. In May of 2019, NSF produced a Dear Colleague letter for researchers encouraging the use of two really important data practices. The first, the use of persistent identifiers, and the second for machine-readable data management plans. So this was a real gift for a lot of us working towards machine-actionable DMPs. So we got a grant from NSF to convene 40 stakeholders for a 1.5-day workshop where we talked about implementing these new practices at various institutions for different stakeholders. And we just synthesized all of those conversations and put together a final report. I've got the short link right there. It's a short report. It's only about 10 or 12 pages, and it's very action-oriented about specific things that different stakeholders can do to adopt PIDs and to work machine-actionable DMPs into their work and into their communities that they support. So I'm going to switch over and talk a little bit about our work modeling connections that are made possible in a machine-actionable DMP through the PID graph. So a lot of the work that we've been doing around machine-actionable DMPs has involved partnership with DataCite. So we've been partnering with them on a number of things, two of which I wanted to update you all with right now. The first is that in the upcoming new DataCite metadata schema, which is due to be released in January of next year, there will be support for data management plans. So that's really important for those of us who are looking to make identifiers for DMPs. We also are working with them on a series of Jupyter notebooks that allow people to play around with machine-actionable DMPs that have identifiers in order to show the connections within a DMP to other scholarly content. So things like data outputs, any software, publications, etc. And that's all using identifiers within a data management plan. So we are hoping to release this work in January 2021, hopefully at PIDapalooza. So I definitely encourage you all to go to PIDapalooza this year. It's going to be obviously online. It's just 24 hours. And we'll be releasing that and talking more about our work. Just as a teaser here, this is one of the visualizations that we built using these notebooks. So in the middle there, the purple dot, this represents one data management plan. Then you can see coming off of it are all of the people associated with that plan, all of the outputs in terms of data sets, publications, funders, organizations, and all of this is connected through the use of the PID graph and the incorporation of identifiers within a data management plan. So we've done a lot of work in the back end to build the capabilities of this new network DMP, a lot of it thanks to the awesome work done by this working group and the common standard. So we're definitely grateful to be building off of that foundation. What we're doing, we're building it all within our open source code base that we have with DCC. They run DMP online. We've also got international partners as well who are all using that DMP roadmap code base. And that is just an application. It's a platform to facilitate the creation of effective DMPs. So there's templates for different DMPs. So we've recently added several new features to Roadmap that support networked research activities or a machine-actionable DMP. We've put identifiers everywhere we can, RORs, funder registry IDs, ORCIDs, the new DMP ID. We've built a new API that is compliant with the RDA Common Standard, and we are using that in a pilot that I'm going to talk about in a second. And you can now export plans as RDA compliant JSON. The things that we are building to increase the capabilities of these new DMPs are, most importantly, support for multiple data set or output descriptions. So this, what I mean by that is a more granular description in a controlled manner of specific outputs that are going to be produced as a result of a research project. We're adding additional PIDs wherever it makes sense. And we're also pursuing several important integrations and pilots. And this is also where that common standard comes into play and is very important. So we are really working towards testing out a lot of our assumptions with machine-actionable DMPs in sort of a real-life working environment. This is all very new, as Claire was mentioning. A lot of this has been very conceptual. So we're trying to take it from conceptual and test it out on the ground. So our big project in that space is the Fair Island project, which I've mentioned before. We recently hired a really great project manager to help kind of get that off the ground, Erin Robinson. Some of you probably know her from ESIP. She's going to be coming on and helping us move this forward. But what we're doing here is we're working with a field station and developing optimal data policies and utilizing machine-actionable DMPs to really test out the downstream effects of good policy and machine-actionable DMPs in terms of the timing to release data. So we've got this really nice controlled environment to test out policy and infrastructure within that very controlled environment. We've got a lot of partners and people that we're collaborating with on this project. RDA is really fundamental to a lot of this work because we're building off of the infrastructure and standards that were built at RDA. We're also working with several UC partners, such as the University of California Natural Reserve System. They manage all of the field stations of the UC system, of which there are many. I think there's about 70. We are working with the Tetiaroa Society, so they actually run the first field station that we're going to be rolling this out. It's the Tetiaroa Atoll. It's a beautiful island in French Polynesia. Obviously, we're working with DataSite as well on this. So definitely you'll be hearing much more about this project in the coming year. So I think we've shared the slides. If you're interested in our work, the best places to find more information about it are the DMP Tool blog and the Fair Island project site, and that's just fairisland.org. And that is it for me.
Thank you very much. Great presentation. One question. Who wants to ask?
What's that?
No, we have a room for one question. Who would like to ask?
Oh, okay.
In the chat, there was a question about the DOIs, whether the DOIs are the only identifier you're using as a DMP ID, or you considered any others?
So we are using lots of identifiers within the DMP. So we've got roars and orchids and sunref, but for the actual DMP, it is a DOI created by DataSite. And that's really important because that is what allows us to hook in to the other identifiers and utilize the PID graph. So we're going to be using that in order to connect DMPs to outputs like data sets or journal articles. So we're able to kind of build on the existing infrastructure without having to kind of build our own new separate system in order to track those.
Okay, thank you. The next speaker will be Lucas and Alexander, who will be talking about the repository for MADMPs. Alex, Lucas, are you ready?
Hi, can you hear me?
Yes, not very good though.
Oh, wait, then I'm trying to...
Can you sit closer to the microphone or speak a bit louder?
Work now?
Yes, now it's much better.
Okay, great. Okay, so welcome. I'm Alex Setzer, and my colleague Lucas Behrend is also here in this room, and he can answer any questions that I might not know the answer to it. And we'll be presenting a repository for MRDMPs. So as most of you, or all of you probably already know, DMPs are usually static documents in the form of PDFs, and MADMPs are an improvement in the JSON format that allow automatic processing. And what we have developed is a prototype of an MADMP repository to manage MADMPs and allow the search of them. So what are the challenges with MADMP management and search? MADMPs contain nested objects and nested arrays. So you might have 4 or 5 layers of nested objects. And this is challenging to work with because obviously it is hard to fit this into traditional relational databases and query them efficiently. So you have to make use of new or different kinds of technologies. And also tools should both provide a user-friendly interface and full flexibility, meaning you can query you can make powerful queries, and you can hide any arbitrary fields, but they should also be easy to use for users. While our tool is only a prototype, it tries to make some attempts in this direction, but it's not fully user-friendly to be used by any end users. So the main features are submitting MADMPs, hiding fields for other users. On submission of the DMP, if you have any data that you don't want anyone to be able to access, you can hide it for others, and also automatic assignment of DOIs. If a DMP that you want to submit to the repository doesn't have a DOI, then it automatically gets assigned because via the DataSide API. And our powerful search which we implemented works in 3 different modes: by field-wise search, by combined search, and also by a full-text search, which just queries the whole DMP. So this is our user interface. This is what it looks like if you submit a DMP. You get a preview, which is collapsible, of the JSON structure of the DMP. And you can also verify or validate the DMP from the client. Hiding fields can be done by specifying JSON powerful expressions, which are really powerful expressions that can, for example, hide top-level fields, hide nested fields, or even hide arbitrarily nested fields, and also select objects inside of arrays. This is the full-text search, where you can just enter any string, which then gets matched to the documents using the powerful Elasticsearch search engine. And for example, you can see on the right side, even if you it does fuzzy matching. So if you type in any text that doesn't fully make sense, you still get some somewhat useful matches. Then it is also possible to search for specific fields, such as the name of the author or the title of the DMP. And it's also possible to specify combined search conditions, such as does the DMP have ethical issues? Is there an embargo on it? When was it last edited before this date or after this date? Or were any data sets in the DMP published on GitHub? So yeah, now we've seen the functionality of the system. So what are the use cases? You can use it, for example, to find similar MADMPs, to efficiently search really large amounts of MADMPs, because the system is supposed to be highly scalable. You could scale up the Elasticsearch cluster quite high if you need it, and also publishing MADMPs with hidden fields that only the submitting user can see. Yeah, and the source code is public on GitHub, and there's also a web page if you're interested, which describes the technical details of the system. So thank you.
Thank you very much for your presentation. And as previously, we have room for one question. No questions? If you want, you can also ask a question to Alex. He has a poster, as far as I remember, 21. So you can come to his poster. Okay, let's move then to the next speaker. So the next speaker will be Max Moser, and he will be talking about the framework for integrating MADMPs with data repositories.
Oh, damn.
You have to start sharing your screen.
Yep, I'm just preparing everything. Okay, can you see it?
Yes, we can. You may want to make it full screen.
Yes, I'm at it. Okay, so, hey, my name is Max, and I will talk a little bit about the framework for integrating DMP tools and data repositories. If you want to check out the concrete module that we're writing for Invenio, then here is the link. And the handout, which Thomas has already mentioned, is also linked here. So yeah, I'm a software developer at TU Wien for the Fair Data Austria project. And I'm tasked with setting up Invenio RDM as the data repository of our choice. And while Invenio is still being under development, we thought it would be cool to integrate Invenio with our upcoming DMP tool and get them to communicate with each other. And then we also figured that it would be even nicer to not only integrate these two tools, but to integrate, to create a tool-independent integration out of that. So you can integrate any DMP tool that follows the MADMP standard and data repositories to communicate and share information. What the basic use cases, what they boil down to is just reducing the effort required by researchers whenever they have to fill out metadata, so that they do not have to fill out the same metadata twice in the two tools, but rather have them communicate and share the information. Feasibility of these use cases has already been shown in some results from hackathons done this summer, for example, for Invenio RDM. But now we wanted, or also Datawars, I think, now we want to do this more production-like and more application independently and not so fixed on one or two specific tools. So the basic use cases, for example, when a researcher gets a new research project and they create a new DMP inside a DMP tool, and they already specify some information that they have plans during the research project to create a couple of data sets and then deposit those data sets in our data repository. We want the DMP tool to send a message to our repository, which can use this message to create still empty, that means without files, deposits without files yet, but that already have some of the metadata filled out. For example, the license specified in the MADMP, the dataset title, and so on. And we also want to have this integration in the other direction, where whenever a researcher creates a new deposit in the research data repository, then it should ask the researcher if this new data set is part of a research project that's currently going on. And if so, then the DMP tool should be notified that this DMP, the corresponding DMP, has a new data set appended, and the researchers should be able to decide whether or not they want to add it in the tool. And of course, we also want to keep the information in sync. That is, when you maybe create or when you publish a deposit in the research data repository, then usually the set of files, the data set per se is fixed and you can't change it anymore. That means you really know the size of each file that this data set consists of, and you can report this back to the DMP tool. Also, if the title changes or something, we just want to have this change reflected in the other tool. To get this integration to run, however, to work, we had to overcome a few challenges. For example, in the first step, we had to look at how do the MA DMP JSONs look like, what do they provide, what do they require, and the same thing for the data repository. What can we get out of it and what does it require? And how do we map between these two worlds? What we identified was that the most interesting for us, the interesting objects for us are probably dataset and distributions, where the datasets are too abstract of the concept to be mapped directly to the world of data repositories, whereas distributions basically references to concrete deposits within data repositories. So we use deposits as primary subject for the communication. There is a problem, however. In the standard, there is no identifier, no reliably set unique identifier for the distributions. There is access URL, but that could not be set when you create new DMPs and so on and so forth. So it's not reliable. How we came around to fix that is we introduced an assumption that each data set hosts only one, that each host only hosts one distribution per data set. If you want to have multiple distributions on the same host, then you could put them all in an archive file and put them in the same deposit. So it's really unique. The combination of data sets and hosts gives you one uniquely identified distribution. So it's clear whenever a host talks about distributions, which distribution it's talking about. Then, of course, when a change is proposed by the data repository, we had to figure out which distributions they should change, because obviously only their own and not another host's distributions, and also because data sets are a shared concept with deposits in several repositories, we've figured that those properties should not be changed either. So we limited the modification scope to distributions. Request format, well, in one direction, namely from DMP tool to the repository, it's quite clear. We would use MA DMP JSON. In the other direction, we had to tinker a bit. Initially, we wanted to use JSON patch, but due to limitations that are more closely specified in the handout, we did not take it. And we basically came to use MA DMP JSONs as well, with a set of special semantics for how the messages should be interpreted. The ownership management of created deposits was also a problem, a little bit of a problem, where we just decided to have the data repository figure it out. So what does the communication currently look like? Well, it's a bidirectional communication with REST interfaces on both ends, because what else would it be if not REST? Then the content of the messages is largely MA DMP JSONs or part thereof. And to provide information about the authenticity of the messages, the update messages, We chose to include shared secrets in the authorization HTTP header, which also provides information about the author tool, so to say. So we know which tool sent this update, and this enables us to run multiple integrations in parallel. Yeah, versioning is done of DMPs is done on the DMP tool, and that's that. Of course, the integration is still work in progress, and we are still facing some open issues. For example, whenever the data repository sends updates regarding datasets, should these changes be reflected in all of the DMPs using this dataset, or should only some of the DMPs reflect this change? For example, we might want to include DMPs for research projects that are already finished years ago. So yeah, we still have to figure that out. Yeah, so that's the speed run of this integration. What we did is create a work in progress concrete integration between Invenio and our upcoming DMP tool, which is developed in-house. And we overcame some of the challenges, including how to map between concepts, how the communication should look like, and what the communication or modification scope should be. Yeah, if you are interested in giving us feedback, what we did well, what you think, what we did badly, and when you think you want to let us know how we could do things better, then I encourage you, please send us emails. Thank you very much for the attention.
Thank you very much, Max, for your presentation. Are there any questions? Don't see any, so to not to run out of time, please now, Georgios, you're the next one to present.
Let me try to share my screen. Okay, sure. Can you see it now?
Waiting for it. Yes, we can see your screen.
Let me maximize it also. I don't see it turn to presenter. Okay, should be on full screen. So hello everyone. My name is George Kakaletris, and I'm technical manager of an Neanias project. Just to give you a bit of context, I'm working for an SME that is activating in the open science domain in this project that I mentioned. And Neanias is our project is an early adopter of the tool that I will be presenting here, the Open Air Argo service. In this presentation, we will see a few highlights of the RDA DMP standard adoption in the Argo service by OpenAir, and also the integration of the standard with the rest of the OpenAir ecosystem of services. Let me clarify here that this presentation shows the work of several people, a few being mentioned below my name there, but their contribution is much more important than mine. And the core team is coming from Athena Research Center and the CNR Institute from Italy. So, as I already said, I will talk about the Argos compliance with the DMP model and format. This will highlight the key points of our journey towards compliance. And then I will show the exploitation of the standard in OpenAir and the alignment of the research graph with it, which is, I believe, of a wider visibility of importance to every tool implementer. So just a quick view here of the Argos model and the challenges we met facing towards the DMP specification from its standpoint. On the left, you can see the model. I will skip the details. I will highlight that the Argos model has one DMP containing the description of several datasets. Those descriptions are not predefined in terms of schema. There is a templating mechanism that defines the details of dataset descriptions according to rules that are established by the domain where the DMP is employed. Different domains have different rules. Mainly those can be coming also from the funders of the grants. Given that, the challenges were that in this model, only a few fields, the attributes are known at design time, and the rest, existence, type, cardinality, may be defined by the user at will. Furthermore, it was discovered that during our journey that several MADMP attributes were either absent, which is not by itself a big problem because someone could define more fields by the templating mechanism. But what was more important is that some of those were at different levels. For example, at the DMP instead of the dataset level. To confront those challenges and others that I did not mention explicitly, we followed three approaches. We added a new feature to the system, which is the semantic tagging of template-defined fields. The second was to apply heuristics during import and export, which allow picking and fitting the best candidate attribute for a MADMP element. Both heuristics and semantic utilization required that we created a special importer-exporter for MADMP. And finally, a few changes in the model, in the core model, were not, we could not avoid them, and we had to do them. Most of the work was focused in the two editors that the system, user interface exposed editors that the system uses, and also the custom importer-exporter that I mentioned already. Oh, sorry. I don't know why this is happening. Okay, there we are. So in this slide, we can see the life cycle of a data management plan in Argos. Quickly going through it, one can see that it starts from a draft form and gradually escalates to more official forms. For a significant portion of its lifetime, it lives inside the information space of the tool. But after a point, it gets a DOI and gets publicly visible. I mention all this to say that in the end, this can be potentially exported to a repository. And to be precise, Zenodo is already integrated in this process with Argos. There, apart from its textual form, the DMP it can also carry its newly standardized MADMP, formalized MADMP specification, and can be reused at will. So we have an eye in integration with the repositories, and the previous presentation is quite contributing to that approach, to that outlook. Then let's go to the exploitation. In this diagram, I show some of the mapping of MADMP elements to the OpenAir research graph. OpenAir research graph is the full list of concepts behind the OpenAir system that many of you, I hope you are familiar. Check the legend below for the entities. What I want to show here is that there are a few elements already. They are in the research graph now. And as we are in close contact with the OpenAir services group, more will emerge in the near future. To pick some, there are, of course, deviations. For example, OpenAir doesn't care about projects now. It cares only about funding. It doesn't care about security and privacy. And the model, I mean, they care, but they do not in the model. They care about license, of course, and things like that. But this will, we hope, will change. So the next is about how we exploit this for discoverability. First, I would like to stress that SCORE defines DMP as a resource type, as you may all know by now, which by itself is a very important asset on our side for data management planning. DMP is also now a primary research output entity in the OpenAir ecosystem and is also searchable. So whoever now follows the OpenAir guidelines version 4 will be certain that their DMP artifacts will get properly handled by the OpenAir services. I'm talking about providers. Continuing on discoverability of data management plans, as I mentioned, DMP is searchable in OpenAir ecosystem. However, here I would like to stress that due to lack of alignment of providers to the guidelines, which are quite new, currently OpenAir uses text data mining in its attempt to locate hidden DMPs, which are usually being harvested by its engine as publications or other research output. outputs. We expect that this will gradually change for the new DMPs. As you see here on my slide that I have some highlights of how they were found, other literal type, article, and things like that. Go to the next one. In order to reach this point of integration, the research graph has been reached. Here you see only the new things that change. We have a new entity, the DMP, and there are new relationships. Has DMP, has project, has data, has in the respective entities, and this will evolve further. Oh, I'm sorry, something is happening with my mouse. It's continuously scrolling. Okay, I won't go through the details of this. Just keep in mind that in this journey we noted that the models that the tools have different, and we have to apply some workarounds. The DMPs are becoming mainstream, and support by repositories is expected to increase their importance and machine actionability. And last but not least, we need to see some details about the schemas, versioning, and feasibility over those for going forward and having wider adoption. So a few additional resources, you can find them here. We already have a publication presenting the work in detail, the work with the research graph. And that's all. One final note is that Argo service is based on an open source tool, which is called OpenDMP. And you can find it in the code can be found in GitLab. And that's all for me.
Thank you very much. Are there any questions? Okay, don't hear anyone. Let's move to the next speaker, last but not least, Marwa, who is going to talk about integration between MADMPs and the research object crates. Please share your screen.
Yes, I will do that. Okay, can you see the screen now?
Yes, it works.
Okay. So good afternoon, good evening, everyone. My name is Marwa Jawa. Sorry, 1 second, I have a problem. Okay, now it's working. Hello, everyone. Sorry for this technical problems. My name is Marwa Jawa, and today I will present to you research object crates and machine actionable data management plans. So the agenda of our presentation is as follows. In the introduction, we will discuss what R crates are and why we need them. Then we will discuss why it is beneficial to exchange information between R crates and MADMPs and what are the use cases of it. After that, we will discuss the mapping between R crates and MADMPs. And finally, we will show the evaluation that we did and discuss the results of the mapping. So we know that researchers need guidance on how to make their data fair. They also need tools that relieve them from time-consuming data management tasks. And there are multiple solutions that help researchers in describing their data and making it fair. And in this presentation, we will focus on those that use semantic technologies and linked open data. And some examples of these solutions are arc rates and MADMPs, and both of them help with the automation of data management tasks. And in the following, we will dive more into what arc rates are so that we understand. So arc rates organize file-based data with associated metadata. It uses linked data principles and it has JSON LD format. It is a simple way to assert the authors, for example, the people, the organizations, and it also captures complex provenance for files. For example, there's software and equipment, and there are also many other uses. There are different implementations which allow the consumption and production of arc rate. For example, there is a Python library called arcrate.py, which allows the creation and the use of arc rates. And there are many other implementations. So now that we have an idea about what arc rates are, we can learn more about the use cases of exchanging information between arc rates and MADMPs. So let's start by the first use case. In some use cases, the data already exists and arc rates are either created manually or automatically, as you can see in the graph. And in this case, we can use arc rates to fill in parts of MADMPs. This allows us to significantly reduce the data management effort on researchers. So as mentioned earlier, the first use case is about the use of arc rates to generate parts of MADMP. And the second use case treats the other way around. So since MADMPs are created throughout the life cycle of the research, they can be used to facilitate the creation of arc rates. And this is because MADMPs can describe future actions. For example, what data will be created, which license will be assigned, who will produce it, and so on. So this initial information can be added to arc rates that will later on be updated with further information when the actual data will be created. So now that we understand the use cases of exchanging data between arc rates and MADMPs, our goal is to identify the concepts and fields of arc rates and MADMPs that can be mapped to each other. We created the mapping and we found out that there is a significant overlap between arc rates and MADMPs. Then what we did was to develop a migration tool which performs the conversion between arc rates and MADMPs. And this tool allows to generate arc rates from MADMPs and MADMPs from arc rates. So we tested this tool with 10 MADMPs from RDA DMP Common Standard Repository and Data Stewardship Community. We also tested this tool with 5 arc rates from Research Object Crates, Crate website, and we also manually filled some arc rates and tested with them. Here you can see an example of a simple evaluation. So the listing to the left presents part of the original MADMP, and it was used to generate the arc rate. And the listing to the right shows an example of the generated arc rate. If you look closely, we can observe that information on datasets and authors can be almost completely exchanged between their representations. And this shows that although the full mapping between the specifications is not possible, the fields that overlap allow for meaningful conversion. And also they can facilitate automation of data management tasks. So coming to the end, today we covered the definition of arc rates. We showed that arc rates and MADMPs can be mapped to allow exchange of information between them. The results show that we have a significant number of properties that can be mapped directly, and the future work will focus on further development of arc rates and MADMP and to consider other use cases such as linking MADMPs from arc rates. Here we reached the end of our presentation. If you want to find out more information, you can visit our GitHub repository. I provided the link in previous slides. You can also check our paper. So it was presented in first virtual workshop on research data management for linked open science. Please go check that out if you want to discover more information. And to conclude, I really want to engage in conversations with you and to discuss this more. And if you have any questions, please drop some emails, or maybe I can answer them now if we have enough time. Thank you.
Thank you very much for your presentation. One question, anyone wants to ask something?
I'd like to ask a quick question. It's Paul Walk here. So thank you. That was really interesting, and I'm actually very interested in this relationship between RO-Crate and DMP, and you've already gone a long way towards establishing that, so that's really encouraging. I wondered, your very last slide, the very last point you made was that there were other use cases such as linking to a DMP from an RO-Crate manifest. That's the angle that I've been thinking of, because it seems to me that the MADMP can provide some useful evidence of provenance if it's included in an RO-Crate, potentially at least. So my question is, have you actually looked at how an MADMP could actually be included in an RO-Crate as a file rather than just a link to an external source? Because the reason I ask this is that a great many use cases to do with the MADMPs using our standard will not necessarily publish those files anywhere at a particular URI. The identifier can be other types of identifier, so it doesn't have to be something that's resolvable on the web. But they may be able to provide the MADMP as a serialized JSON file, for example, which could be included in the RO-Crate. So I just wondered if you've looked at that as a possibility.
Regarding this question, maybe Tomasz can elaborate more on it.
Okay, no problem. So we have already discussed this with Paul, so just for everyone, no, in this work that Marwa did, we focused only on the mapping. And yes, the idea that you're suggesting, Paul, just to include a link to the MADMP is a really great idea and a low-hanging fruit to establish such an integration. And this is something we should definitely follow up.
Tomasz, could I ask one more question?
Yes, please.
This is Ted Haberman. I put in the chat a link. Just less than 2 years ago, there was a discussion at an RDA meeting about packaging schemes, research data packaging, and there were 6 discussed during that meeting. The link is in the chat. One was a data crate, and one was a research objects development at research objects, and I wonder how this RCrates idea is different from other existing data packaging schemes, many of which were discussed just less than 2 years ago at RDA.
So I have to say that RO-Crate is for us the related work. It's not anything that comes from us. As far as I know, Research Object Crate has now it's a new incarnation of Research Object, and there has been a lot of development within the last half a year. So the structure of the Research Object Crate is now based on schema.org, and they have completely reworked it compared to what was there some time ago. That's what I know, but I haven't seen this session at the plenary, so I don't know what are the other packaging solutions, to be honest.
I can add just, I don't think we want to go too far down this road because it's slightly tangential to what we're doing here, but it came about as very definitely a merger between the efforts of Data Crate and Research Objects. It's come out of the Research Objects work led by Carol Goebel at Manchester University. And it was presented in detail at the RDA plenary in Helsinki, I think it was. And as Thomas says, it's quite relatively new, but they've been developing very rapidly and getting some real interest. So I don't know about the other 5 or however many packaging standards that were discussed, but RO Crate coincidentally seems to be getting a lot of attention in related spaces like this.
Okay.
It just seems to me we might be reinventing the crate.
Well, it's building on the crate. I think they're trying to reinvent as little as possible. It's really building on the data crate here, and the major change, as I understand it, and I'm very sketchy on the details here, but my understanding is that the main thing which they've brought to the party is going all in with schema.org as the vocabulary which they're using for just about the whole thing.
And a related question, is schema.org sufficient to describe such an object? Can you describe the promise of a data set?
I think this is really out of scope for our discussion, to be honest.
Okay.
We're discussing data packaging, and that's not really our working group's remit.
Okay, we have 7 minutes left to finish the session, and I still didn't get to the part 3. So let me go quickly through the maintenance of the recommendation we did. So we have a new release, which is version 1.1. If you go to the GitHub repository, you can see in 2 places that there is on the right-hand side, you can see version 1.1. You can switch between the versions. So if you want to see the previous one, 1.0, it is still available, but the new one is now 1.1. And in this part, I want to talk about what are the changes and how we're going to keep on maintaining the recommendation, and what are the open issues that we would need your inputs in the next calls. So we have made 2, let's say, types of changes. We have relaxed cardinality for the properties. We changed them from required to optional. This is because of the use cases that were mentioned in the issues coming from the participants of the hackathon. So it's mostly related to the project and the funding, and the situation that when you're applying for a project and you're writing a DMP, in some cases, for example, in the NSF case, you still don't know what will be the grant ID or when the project will start. And that's why we had to relax the constraints. And for all fields that are related to dates, we added a description which is pointing to the ISO 8601 and is providing guidance on how to format the string. This is not really a change. We made this knowledge explicit because previously it was assumed that it's ISO 8601, but it was not directly in the documentation. So none of these changes is breaking. They are backwards compatible. We have also made a change to the Json schema. So this is important for the developers. You can see now a new version of Json schema. We made all the changes we described. Plus, we also removed the minimum items restriction. So now the schema will, so the examples will validate against the schema in case if you pass an empty array or if you simply omit an optional element, the validation will pass through will be positive. By making this release, by making these changes, we have managed to close 5 issues coming from people who are adopting the standards. So thank you very much for the feedback, and we look forward to hearing from others about any issues you may have. And the process for reporting the issues and requests for changes is as follows. We have 3 steps. So basically everyone can create issues in our GitHub repository to indicate when there are any bugs or maybe something is not clearly described, like it was with the dates. You can also make suggestions about changes needed or extensions to the standard, whatever comes to your head. And then the community can discuss publicly under each specific issue. If there is something not clear or bigger discussion is needed, we'll organize video calls if needed. And chairs of the working group review and label the issues. So we're kind of guards to make sure that the discussion moves forward and is streamlined. And if we identify need for a new release because there is a consensus on a change, we will make a new release to the standard. We are planning to have 3 types of releases that follow the semantic versioning approach. So the first one is when we make small bug fixes that are backwards compatible. For example, if there is a spelling mistake, and we will publish such fixes immediately when such an issue is reported and we resolve it. And this will result in a change, for example, from 1.1 to 1.1.1. So the third number indicates these patches. Then we have minor version change when we are adding some functionality which is backwards compatible. So this is an example of the change we made now. We have relaxed some constraints, and we have changed the version from 1.0 to 1.1. And we're going to group such changes, group such requests, and publish them in batches, and we will be announcing them at plenaries. So we are not planning to make this kind of changes more than twice a year. Hopefully not even twice a year. And then the third type of change is the major change, when the changes are not backwards compatible. And this is when, for example, we are removing entries. And this needs broader discussion. This will be also announced at plenaries. But for this, we really have to make sure that changing something which was assumed for some time is correct, is the right thing to do. And then we will make a change, for example, like from 1.1 to 2.0. That's how we're going to do it. And there is a set of open issues still that require discussion. I don't have time now to go through them. We are going to organize a call in November to resolve all open issues. We will send a doodle to the DMP Common Standards mailing list. The top 3 issues we have is how to indicate that extensions are used. How can we track changes of identifiers over the lifetime of a digital object? So for example, if a data set have a DOI handle and the internal system identifier. And there is a request to maybe make a change to how we talk about things which are planned and performed, to make it explicit and not to use the arithmetic of dates like we're doing it now. So please go to the GitHub, to the issues, please comment, please provide your feedback, and I hope we will see each other in the call discussing these issues. Next steps for the working group. The DMP Common Standard Working Group is going to maintain the recommendation. So next meetings will be about the updates to the specification. We also want to focus on supporting adoption and promote success stories or lessons learned. There is a second group at RDA, which is the Active DMPs Interest Group, which was the umbrella group for the working group. And we would like to move the discussions about all topics related to DMPs into that meetings. So if there are any new topics that we should tackle together related to MA DMPs, we can do it in the interest group meetings. We also would like to mention that there are some open challenges from the hackathon that hasn't been still yet solved. For example, mapping to funder templates. There is a great work done to map the fields from the standard to specific funder templates, but no final decision has been made, no final recommendation has been made how to do it so that we all use the standard in a coherent way. That's all from my side. Unfortunately, we're running out of time. So in case of any questions, please contact the group chairs. Please adopt the recommendation. And we're looking forward to seeing you in the next meetings, in the next calls. Thank you very much. That's all for today. Sorry we didn't have enough time to ask more questions.